Welcome to The Explainer. Today, we're tackling what has got to be one of the absolute most mind-bending thought experiments in the entire realm of quantum mechanics. We are talking about quantum immortality. Now, imagine facing certain doom, an unavoidable, completely fatal scenario. But for some reason, the universe simply refuses to let you experience the end. Instead, your consciousness just keeps sliding into increasingly improbable realities where you miraculously survive. I mean, it sounds like pure science fiction, right? Well, today we're going to look closely at how a very specific, cutting-edge framework in physics, something called Born rule primitivism, is completely rewriting how physicists and philosophers view our timeline, our universe, and our ultimate fate. So if you've ever wondered how the deep math of quantum physics dictates your actual lived experience, and whether you might literally live forever in a parallel branch of reality, you are in exactly the right place. Let's get started.
Okay, let's dive straight into the ultimate question here. Does quantum immortality actually guarantee your survival in a parallel universe? To really grasp this, we've got to talk about the classic quantum suicide thought experiment. The concept basically suggests that in a branching quantum universe, where literally every possible outcome actually happens in its own separate reality, there is always going to be at least one branch, a tiny sliver of reality where you survive any life-threatening event. Imagine a wildly dangerous experiment, like a quantum explosion. In almost every single universe, it goes off. But in one infinitesimal branch, the detonator jams due to some bizarre quantum glitch, and you walk away without a scratch. Quantum immortality argues that your consciousness will automatically track that one survival branch, simply because you mathematically cannot observe your own non-existence. But is that actually how the physics work? To figure this out, we can't just rely on sci-fi tropes. The real answer lies hidden within a pretty intense debate about theoretical physics, quantum branches, and the strict rules of quantum probability.
To unlock this mystery, we first need to define a really critical concept, and that is self-locating uncertainty. It's defined as the epistemic state of not knowing which future observer moment you'll experience before a measurement happens. Let's make that a bit more real. Imagine standing at a massive fork in the road of reality. A quantum event is about to happen, and the universe is going to branch into multiple versions. You know intellectually that all of those branches will exist, but right before it happens, you have absolutely no idea which version of the future you, your subjective stream of consciousness, will actually wake up in. That deeply weird, uniquely human feeling of not knowing your exact future location in a physically branching universe, that's self-locating uncertainty. It's an incredibly jarring thing to think about from the perspective of an observer. I want you to keep this concept locked in your mind because it's the absolute center of the debate we're about to unpack. Section 1. The Standard Everettian Approach. How uncertainty builds the rules. Let's look at the traditional framework first. Standard Everettian approaches are heavily associated with brilliant physicists like David Deutsch and David Wallace. In their model, that self-locating uncertainty we just talked about, it plays a massively central role in how physics works. The crucial point is this. In the standard view, this human uncertainty is actually used to explain why rational agents should assign specific probabilities to future outcomes. Now, just a quick refresher. The math that dictates quantum probability is called the Born rule. It's basically the mathematical formula that tells us the strict odds of a quantum event happening. It explains why a quantum coin flip might be 50-50 instead of, say, 99-1. And according to Deutsch and Wallace, your human uncertainty is literally part of the derivation of that rule. In this view, the rational logic of not knowing where you'll end up generates the mathematical probabilities of the Born rule itself. The uncertainty builds the math. Moving on to Section 2. Enter Born rule primitivism, flipping the script on quantum probability. So recently, a new framework has emerged that challenges everything we just talked about, bringing this massive philosophical shift that's really shaking up the theoretical physics community. On one hand, you have the standard Everettian framework, which says your uncertainty generates the Born rule probabilities. But Born rule primitivism argues the exact polar opposite. It says the primitive Born rule dictates your uncertainty. In this newer framework, the order of cause and effect is totally reversed. The mathematical law doesn't emerge from your rational uncertainty. Instead, your uncertainty is just you experiencing a fundamental law that was already there. Think about how huge of a shift that is. It's moving away from seeing human perspective and decision-making as the creator of the rules to seeing a cold, hard mathematical law as the ultimate dictator of the human perspective. The math comes first, always. Okay, let's break down exactly how this builds into a complete logical structure. The primitivist picture essentially boils down to three core tenets. Step 1. The Born rule is fundamental. It's an ontologically prior basic law of nature, meaning it is bedrock reality. It isn't derived from human decision theory or rationality. It just is. Step 2. Because the law is fundamental, self-locating uncertainty is merely epistemic. That just means it represents a gap in your knowledge. It's a limitation of your perspective before a measurement happens. It helps you guess what's coming, but it absolutely does not build the rule itself. And finally, step 3. When you ask yourself, what should I expect to observe, the answer comes directly from the primitivist Born law. You expect outcomes according to the mathematical Born weights, simply because that is exactly how observer location is distributed by the bedrock law of the universe.
Which brings us to section 3, solving the immortality puzzle. What this means for your quantum survival.
So we have this new framework where the mathematical law is primitive and fundamental. How exactly does this solve our opening mystery about living forever? Well, according to the primitivist framework, self-locating uncertainty functions purely as a bookkeeping tool for your predictions. As the source material puts it perfectly, I am uncertain which outcome I will find myself experiencing, and my expectations should follow the Born rule because the Born rule is a basic law. It really hits the nail on the head. Quantum uncertainty is not some magical guardian angel looking out for your survival. It's just an accountant sitting at a desk, making sure the math adds up, according to the fundamental laws of physics. Your limited view is just a lens looking at an already existing probabilistic law. You're simply doing the mental bookkeeping for what the universe has already decided by law.
As a direct consequence of this, when we look back at the whole idea of quantum immortality, the primitivist framework has a very clear, very strict answer. Let's go back to that quantum explosion scenario we talked about earlier. Yes, in a branching universe, there may technically exist a wildly improbable, extremely low-weight branch where the detonator jams and you survive a totally fatal event. Those tiny branches are out there for sure. But, and this is the absolutely vital takeaway, the primitive Born law dictates that your future conscious experiences will overwhelmingly track the high-weight branches. The fundamental law of the universe essentially forces the distribution of your observer location into the branches with the highest probability. So while that 1 in a trillion survival branch exists somewhere, the cold, hard math ensures your path of experience tracks the highly probable branch, the one where, well, things frankly don't end so well for you.
And here is the final verdict. Because the expectation comes directly from the primitive Born law itself, and not from the mere existence of your subjective uncertainty, you should not generally expect to find yourself in those improbable immortality branches. Quantum immortality relies entirely on this really hopeful idea that as long as a survival branch exists somewhere out there, your consciousness is going to magically find a way to navigate there to avoid oblivion. Born rule primitivism definitively shuts that down. It says the underlying foundational law of the universe distributes your experience based strictly on probability weights, meaning the math says you will experience the highly probable, ordinary outcome, not the miraculous sci-fi survival. You just don't get to cheat the system.
It's kind of sobering, right? But it's also an incredibly elegant way to understand our place in a vast branching universe. The laws come first, and our expectations just have to fall in line. So I want to leave you with this thought to ponder today. If establishing the Born rule as a primitive physical law can completely debunk a concept as massive as quantum immortality, what other wild sci-fi concepts or deep quantum mysteries might this framework rewrite next? Thank you so much for joining me for this explainer. Keep questioning the universe, and we'll catch you next time.